Hey guys, here's a quick intro to the video I got coming up here. It's all about measuring power and the different types of meters here, but I'll just give you a quick sneak peek here in the video. So let me show you here. So keep an eye on this meter. What I'm doing here is I'm just turning the power on right here. You can see the voltage in the cap bank move when I turn the power on. You see it's charging, but keep an eye on the meter. Everything's hooked up normally, and I'll show you that in the video. Do you see it move? I'll keep the voltage in the background. Nothing's moving. Zero. You don't see anything. You know, everything's all hooked up. So look at the scope. Now I'm tapping it on and off. See? Bottom's at current, top is the voltage being induced. Off, on, off, on. So you see it's not moving at all. There's power being put out to the output. Input unmeasurable with those meters. And even with a multimeter, it won't show you shit. But what I can do if I don't have a scope or a clamp meter is right here. Little tiny 20 milliamp LED. Look. Turns on because there's power going through it. You know, and if there's power coming back to the battery, the red one will turn on. Like all that's coming up in this video here. And you can see, I'm tapping it on there, you can see it's restricting some of the flow, but it's still turning on. You know, if you got power going through the system, this light is going to light. These LEDs take an extremely small amount of current to light them up. And when you put them in series like this, you can see the very, very small amounts of power flowing. See, it's hardly even reading on the scope up here. And yet it's still charging. The LED's lighting up, but you're not going to see it on any meters. I don't care how sensitive these galvanometers are. They're just not what you need for this. And sorry about the long rant, but this is the intro to the video, so hope you guys enjoy it. Hey guys, here's the setup here I've got going on. This is just the start of the video, and then I'm going to do a portion of the video after, a longer portion with a lower input level with the LEDs and stuff like that, like I showed in the beginning. These here are just here to drain the cap bank that's not being used. I got kind of a mess here going on, stuff going on in the background. So, but I'm hooked up to the input right here, so you'll take it off, zero it out, hook it up, and see, this gauge is lower than this one is. This is the output from the driver circuit. Here's the clamp. So what you're seeing right here, I'll pause this and I'll line this up. This line right here with one of the input pulses. See right there, this is an input pulse. Input. So you can see the voltage is triggered on the input right here. It comes down. Here's the current lagging behind. And it lines up perfectly. So what you're seeing is a 1 amp input with this pulse here, right here. So you can measure that right here. Right there. After this video too, I'll do a calibration of the clamp meter with just a DC current matching these meters. So I'll do that with an LED light with a steady DC current out of this. So I'll do that right after this, and before the next clip what I'm going to do. I forgot to do that, but I'll do that right away here. But you can see 1 amp right there. So now I'll unfreeze that and put it to the output. Oh, there you go. That's higher on the output. Right there. And this is the overall right here. VA right there. Make sure to zero it. Put it back on. See? Back to the input. You can see it's always higher on the output. And that's the actual pulse going out too. It's just the way it is when you're pulsing it. And okay, now I'm gonna do this with the light. I'll be right back. Okay, I've got it hooked up. See right there, 500. It's really close to 500. I'll take it off. 0. Nothing up here. Put it back on. 500. And right there, 500, right on the nose. Here's the cursor right here, and you can see it right there. If I move the cursor, it moves too. And you can see the settings for it right here. 100 millivolts per amp. Right there. And that's what the settings on right here. You can see right here. This one. First setting. 100. Right there. So that's what you need to have. The O-on is nice for that. It makes it easy to adjust it. Well, you can see it's what you need to see. It's right on the money. But when it comes to pulse DC, these things do not work. The rest of the video is with a lot less current going in, showing some different stuff. So hope you guys tune in, check it out too. And thanks for watching. Okay guys, so I got it going here. It's all hooked up. I'm on the input right now. I'll just tap it here so you can see the, I'll take this off and on and you'll be able to see the gauges move. That's the input one that I'm hooked up to, and here's the output. So you can see, I'll turn it back on, and it's pause this. So here's the on spike from the battery right here. This comes from the driver circuit. It's right here. I'll line that up. With that right there. See, here's the on, the voltage. Here's the current. Kind of lags behind a bit. Comes down. You get that little bit of right here is where it's going back into the battery, back feeding. But that right here is the 267 milliamps going in from the battery, pulsing it. And that's right here, and right here. Everything else is just a coil bouncing around, ringing at its frequency. The input frequency is 4.18 kilohertz, and the coil's ringing at 24 kilohertz. You know, 6 times the input at this voltage. It varies at different voltages. That going again, now I'll put this on the output. There you go. That's the output right there. Higher than the input on the driver circuit. And even the output here, the down spikes are higher. And if I was to actually make this more sensitive, it would be even more of a difference. It's just hard to get it all on the screen. But you'll see even it's a little more accurate at this sensitivity level. It's pretty close at that one anyway, right there. 100 millivolts. I had a few comments too about people saying to use a fuse right here. Well, yeah, you can use a fuse, but you'll never know what current it blew at. I'd be able to tell you what current it blew at with this, though. But if you don't have that, you're just guessing. You know, I can put half an amp through these 20 milliamp LEDs. They won't blow because it's a transient spike. So show that actually right now. When the orange one turns on, that means there's power coming out of the battery. You're gonna see them both. See? And there's a voltage drop across the LED, plus it restricts the current, so a lot less current going in. But let me bring this up a bit, and you'll see the red one turn on. See the power going back into the battery now through the red one. Right? You can see the amounts. There's 29 milliamps, 20 milliamps going in reverse here. Let me just put it. Yeah, pretty much 20 of that, and 425 milliamps is going through this one without it blowing. You know, it's pretty hot though. Like, it's restricting a lot of energy. But let me show you something else. If you don't have a scope, what you could do. I'm gonna just turn this all the way down to where, let me just get it so that when I move this, turn these all the way down, the gauges won't move. There, you can hardly see them move at all. And that's just because of what the driver circuit takes. I can't take it down anymore. But now watch. Look, the light is still on. You know, and I bet you I can get it to start. Just have to tap it a few times here and I might be able to get it to start. Oh, I had it. It's really close to trying to start the oscillation on the ringer circuit. bring it up just a hair, see if I can get it to start. A little bit more. It's really close, this trying to start. Just because the oscillation in the Joule ringer has a hard time starting up at such a low energy. There it goes. But you can see, like, those gauges aren't going to move. Look, it's still reading it. Especially on these lower settings. See, there's still 28 milliamps going in. And at this low setting, a lot of it comes right back out. This one up here is telling you what it's actually using. And you'll be able to see the cap bank. I had the power up already, so the cap bank is kind of high. But like as it equalizes, it'll start to climb again with this very, very little input. You know, and this is only 26 volts going in. Somebody else was asking too about the coils. There's 6 ohms of 24 gauge. And 1 ohm of 19 gauge. And they're wrapped in that order. 24 gauge on the bottom. And the more copper, the better. I've got a bunch of these circuits I've made. And each time I made one, I just added more and more copper. And it got much more efficient every time I added copper. But I think that's all I wanted to cover. Just simple ways to measure your power if you don't have a scope. Like, you don't want to keep these on all the time because they're restricting power going into your circuit. But you could, if you're running at a very, very low current setting where you can't see it on the gauges, if you think you're not using power, just put one of these in series, and if it turns on, you're still using something. You know, and a lot of times you're sending power back too with these type of circuits, and you can see that with these. But the ultimate way is like with this. You just have to make sure you put your clamp meter somewhere where the field isn't affecting it. So you have to try to make sure this is in the center here. Hard to tell right here. That's important. When you're zeroing it out, make sure that's in the center. That's the only downfall with them. Sometimes you have to run your wires to get it out of the field. And these LEDs work good for higher currents for doing that. You know, take 2 of those out of this comes out of a heavy equipment 24 or 12 volt. This will handle 6 or so watts, I think. I'm not sure exactly what it is, but that's about it, I think. The Handtech does a pretty good job too. It's just these ones are a lot cheaper too. Just the old one has these settings built into it for current. That's a lot simpler. So does a Handtech, but the old one makes it quite a bit simpler to use. And these ones are probably 5 times the prices of the Handtechs, but the Handtech will still work just as good. Anyway, thanks for watching, guys. Just wanted to share that. Appreciate the new subs too.